This is passage 5. It's a research passage.
For our DRC approach, R means research and read. We're not going to read carefully, but we're going to look at the process and the differences between the studies.
We know this is research because we see experiment 1 and experiment 2, so we're going to quickly orient ourselves. It's about UV light and sunscreen. Students did 2 experiments to measure absorbance of UV light. Looks like they have an apparatus. They have steps. Odds are you're going to have a question. Anytime you see numbered steps in a passage, you're going to have something that comes from those numbered steps. In experiment 1, 5 sunscreens were tested with a different SPF. Concentration was the same. Here's the results. So we have absorbance and wavelength. Guess different SPFs. Experiment 2, sunscreens of 8, 15, and 50 were tested. So that's different, right? We have more SPFs tested here at 3 different concentrations. So that's different too. We have SPF and then the different concentrations. Then I'm just going to move to the questions right after that, about 30 seconds. For the questions, I want you to do a read then reread approach. You quickly read through the question and then you reread it, breaking it down step by step. We'll do the reread together. Number 28, according to the results of experiment 1, the maximum absorbance by each of the sunscreen solutions. So maximum absorbance is going to be at the top of these lines, and they all pretty much occur around the same wavelength, which is what we're looking for. And it's the wavelength closest to 310. So your answer is G. In experiment 2, at a given sunscreen concentration, so it means any of the sunscreen concentrations, as SPF increases, the maximum absorbance does what? So we see maximum absorbance, and it increases at each level, so increased only. Question number 30. In experiment 1, which type of UV light, and we see UV light as UVA or UVB in the questions. I guess that's what we're looking for. Was more effectively absorbed by each sunscreen solution. So absorbance is the y-axis. We see that effectiveness, we saw that in the last question as well, is there at about 310. But how do we decide between UVA and UVB? We don't see that anywhere in that figure. Well, if we go to the reading, it tells us UVB light has a wavelength of 290 to 320, which is where the most effective absorbance line is. So the answer has to be H, UVB, between 290 and 320. So H. Number 31. Which of the following conditions differ between experiment 1 and 2? Usually it's easiest just to look at the experiments and find the difference. Sometimes you can see them in the table. I think this one's easiest in the reading. It says in experiment 1, the concentration was the same. In experiment 2, 3 different concentrations. So what was different? The concentrations. B. You might sometimes have to look throughout the rest of the passage to process of eliminate. This one's pretty straightforward. Number 32, in experiment 1, suppose, you have to think through this question a little bit, add some data, an SPF of 20 had been tested, so it's going to be between 15 and 30, so about here. The maximum absorbance would most likely have been closest to what? So the maximum absorbance would be 1, so choice H. Number 33, PABA. It's a common sunscreen that has a maximum absorbance in the UVB light range. Which of the following wavelengths is a possible wavelength for maximum absorbance? Well, from a previous question, we know UVB has a range from 290 to 320. So whatever it is has to be in that range. The only one in that range is choice A. All these others, not in range. Number 34. Assume that in step 4, absorbent measurements were made in 5 nanometer increments. Based on this information, each sunscreen was exposed to how many different wavelengths of UV light? So we started at 290, and they go through 400. So 290 to 400 by 5 nanometer increments is 23 increments. So you can count if you wanted to. 290, 95, 0, 5, 10, and you end up with 23. So your answer is J. Reach out if you have any questions. Here's our silly joke to end with. The teacher asked the class, "Tell me what you know about atoms." One of the kids said, "Very little." The teacher said, "No, besides that." Have a good day.